Let us now see how the where statement works. Now, looking at the characters table, I see that there is a field which is called isAlive, and this field is of type Boolean. That means that the value can be either true or false. So if I go to the preview here and scroll to the right, I can see that for some characters this is true and for others it is false. Now, let's say I only wanted to get those characters which are actually alive. And so to write my query, I would first write the address of the table, which is fantasy characters. Next, I could use the where clause to get those rows where isAlive is true. And finally, I could do a simple select star to get all the columns. And here I see that I only get the rows where isAlive is equal to true. So where is effectively a tool for filtering table rows. It filters them because it only keeps rows where a certain condition is true and discards all of the other rows. So if you want to visualize how the where filter works, you can see it as a horizontal selection of certain slices of the table, like in this case where I have colored all of the rows in which isAlive is true. Now the where statement is not limited to Boolean fields, it's not limited to columns that can only be true or false. We can run the where filter on any column by making a logical statement about it. For example, I could ask to keep all the rows where health number is bigger than 50. This is a logical statement, health bigger than 50, because it is either true or false for every row. And of course, the where filter will only keep those rows where this statement evaluates to true. And if I run this, I can see that in all of my results, health will be bigger than 50. And I can also combine smaller logical statements with each other to make more complex logical statements. For example, I could say that I want all the rows where health is bigger than 50 and isAlive is equal to true. Now, all of this becomes one big logical statement, and again, this will be true or false for every row, and we will only keep the rows where it is true. And if I run this, you will see that in the resulting table, the health value is always above 50 and isAlive is always true. In the next lecture, we will see in detail how these logical statements work and how we can combine them effectively. But now let us focus on the order of operations and how the where statement fits in there. When it comes to the lexical order, the order in which we write things, it is pretty clear from this example. First you have select, then from, and after from you have the where statement. And you have to respect this order. When it comes to the logical order, you can see that the where clause follows right after the from clause. So it is second actually in the logical order. If you think about it, this makes a lot of sense because the first thing that I need to do is to get the data from where it lives. And then the first thing I want to do after that is that I'm going to drop all the rows that I don't need so that my table becomes actually smaller and easier to deal with. There is no reason why I should carry over rows that I don't actually need, data that I don't actually want, and waste memory and processing power on it, so I want to drop those unneeded rows as soon as possible. And now that you know that where happens at this stage in the logical order, you can avoid many of the pitfalls that happen when you're just learning SQL. Let's see an example. Now take a look at this query. I'm going to the fantasy characters table, and then I'm getting the name and the level. And then I'm defining a new column. This is simply level divided by 10, and I'm calling this level scaled. Now let's say that I wanted to only keep the rows that have at least 3 as level scaled. So I would go here and write a where filter where level scaled bigger than 3. And if I run this, I get an error, unrecognized name. Can you figure out why we get this error? Level scaled is an alias that we assign in the select stage, but the where clause occurs before the select stage, so the where clause has no way to know about this alias. In other words, the where clause is at this point, and our rules say that an operation can only use data produced by operations before it. So the where clause has no way of knowing about the label which is assigned at this stage. So how can we solve this problem right here? The solution is to not use the alias and to instead repeat the logic of the transformation. And this actually works because it turns out that when you write logical statements in the where filter, you can not only reference the columns of the tables, but you can also reference operations on columns. And this way of writing operations on columns and combinations between columns works just as what we have shown in the select part. So that was all you need to know to get started with the where clause, which is a powerful clause that allows us to filter out the rows that we don't need and keep the rows that we need based on logical conditions.